The lesson topic for this video is solving logs using exponentials. Okay, so here are the steps. To solve a logarithmic function for x, we first need to isolate the log. This is similar to when we talk about solving exponentials using logs. So we need to isolate the log, meaning get it alone on one side of the equation. Then we need to change it to an exponent or an exponential situation. And then we need to evaluate it. And if necessary, we need to get x alone at the end. Very similar to what we've done in a previous lesson on exponentials. Let's try some examples. Okay, so this first example says log base 6 of 2x equals 4. The first thing we need to do is we need to isolate the log. It is isolated here on one side of the equal sign alone. The log and the base and what the log is of is all together as the log. Okay, we can't just get the word log by itself. So this is the whole thing and we're good to go. So next we need to change it to an exponent. All right, so we are going to write the base first. The base is 6. Remember that the base goes first. The exponent is out here. So 6 to the 4th power equals 2x. So now we need to evaluate. We're going to evaluate 6 raised to the 4th power, and that is, well, 6 times 6 times 6 times 6, which is 1,296, and that equals 2x. And lastly, our fourth step here is, if necessary, we need to get x alone. We do need to get x alone here. We're going to divide both sides by 2, and we get x equals 648. All right, the next one. Log base 3 of x minus 7 equals negative 2. Again, I want to point out that the log is isolated in this example. Here's the word log, the base is this, and this is what we're taking the log base 3 of. So we're going to change it to an exponent. Start with our base of 3, raise that to the negative 2, our exponent, and it is equal to x minus 7. Now we evaluate. We have 3 to the negative 2. Okay, we're going to obviously probably, most of us anyways, use our calculator to go ahead and compute that. And it is 0.111. All right, and then we are going to add 7 to both sides to get x alone. So we add 7 to both sides, and we get x equals 7.111. If you are wondering about why 3 to the negative 2 is 0.111, remember that 3 to the negative 2 means we have a negative exponent, which means we need to move the base and make the power positive and put that over 1, or under 1, excuse me. So that is 1 over 9, and 1 over 9 is indeed 0.1 repeating. Okay, we're going to try 2 more examples that are both a little different, and we are also going to try 2 additional ones on the next screen that get a little trickier yet. So first of all, we're going to start by isolating our log in this example, and it is already isolated. Notice there is no base written in. What does that mean the base is? Hopefully you said 10. It is log base 10 of 2x plus 6. It is called the common log, equals 4. So the first thing we're going to do is change it into an exponential situation. So 10 to the 4th power equals 2x plus 6. All right, 10 to the 4th power is 10 times 10 times 10 times 10, which is 10,000, 4 zeros there, equals 2x plus 6. So now we need to solve this for x. The first step, of course, is to subtract 6. Good old linear solving. I'm sure sometimes you guys miss that. When we subtract 6 from 10,000, we get 9,994. And lastly, we are going to divide by 2 on both sides, and we get x equals 4,997. All right. What happens in this next one? Well, we have log base 10 again, because there is no base written in. Log base 10 of x raised to the 2nd power equals 36. So notice on this one, the log is not isolated. because here's the log and there's something else on that side of the equal sign with it. We need to deal with that square first. So how do we undo a square? Well, we square root both sides of the equal sign. All right, now what that means is we end up getting log base 10 of x equals, what do we have over here? Well, we actually have plus or minus 6. Did you catch that? When we square root both sides of an equation, we always need to include positive or negative 6. All right, so now that our log is alone, it is isolated, we are going to change this into an exponential situation. Now, what I would actually recommend doing here is rewriting log of x equals positive 6 and log of x equals negative 6, and then rewriting them separately. So this one will be 10 to the 6th power equals x, and this one will be 10 to the negative 6th power equals x. And when we evaluate 10 to the 6th, we get, well, 1,000,000, 6 zeros, right? And that equals x there. And now for 10 to the negative 6, again, like I mentioned on the previous screen, when we have a negative exponent, we can think about this being the base of 10 raised to the 6th power over 1, because we had to move the base with the negative exponent to the bottom and make the power positive. Good old power rules. So this is x equals 1 over 1,000,000. And we can leave it as a fraction if you want, or we can change it to a decimal, which is 0.000001. Whichever, doesn't matter to me. Okay, so the last set of examples, these are a little bit different. As you can see, the first one's log base 3 of log base 2 of x equals 2. So do we have a log isolated on this side of the equal sign? The answer is yes, we do. We have log base 3 of this equals 2. Don't worry about what this is yet. So how do we rewrite this then as an exponential? Well, we write base of 3. We're looking at this 3 right here. Again, ignore all of this. Just think of this as a blob. Okay, don't worry about that yet. So 3 raised to the 2nd power, right, equals that blob that we just talked about. So log base 2 of x. All right, so now evaluate 3 squared. Well, 3 squared is 9. So 9 equals log base 2 of x. Well, now this is a very normal situation. We can solve this log by using those same steps we just used. So do we have an isolated log right here? We sure do. So we can change this to an exponential. So our base is 2, because it's right here, and we raise it to the 9th power, and that equals x. So now 2 to the 9th power is 512, and 512 equals x. So not as tricky as it looks at first sight, I don't think. All right, last one. Log base 1/2 of x squared equals negative 6. Is the log isolated? Yes, it is. Log base 1/2 of this equals negative 6. So we will start with 1/2 raised to the negative 6 equals x squared. Probably should put that in parentheses there. So if we compute 1/2 raised to the negative 6th power, I mean, I could talk about power rules again here, but if we just computed that on our calculator even, we're going to get 64 equals x squared. And now to solve for x alone, we need to square root both sides. When we square root both sides, remember x equals positive or negative 8. You can't just say 8. And there's our solution for that one.